Hello and welcome into another week of Whether or Not podcast. I'm your host, meteorologist Scott Sumner, sponsored by Ford. Well, this week I had a pleasure of speaking with the National Hurricane Center, Philippe Papin, and he talked about a subject that I thought was pretty interesting, and so we're going to talk about the Fujiwhara Effect. Let's look. All right, welcome in today on my podcast, Whether or Not podcast. We have a special guest here, Philippe Papin, a Ph.D. from the Hurricane Center, NHC, down in the Miami vicinity. And Philippe, thank you so much for joining in today with me on my podcast. I'm going to talk a little about a subject that is kind of interesting and not as well known as some people might think it is. It's the Fujiwhara Effect. But before we get into that, I just ask you, tell us a little bit about yourself and how you became a hurricane specialist with the National Hurricane Center.
Well, good morning, and thanks for letting me join this morning. So basically, I've been sort of a weather nerd from a very early age. I can remember back when I was actually in elementary school that I would actually be very interested in following the tropical storms and hurricanes that were occurring in a given season. And actually, some of the sort of fascination I got in meteorology started as a fear. I used to be very deathly afraid of lightning and storms and whether or not they were going to affect my local area and whether or not we should get out of harm's way. And then over the years, basically by following these events, it turned in from something that used to be a fear into a passion for something that I want to kind of know and understand more about. And so from a pretty early age, I kind of knew I wanted to be a meteorologist, and I knew I wanted to do some sort of weather forecasting. And then over the years, I became more and more interested in tropical storms and hurricanes. And I ended up basically going to school for that purpose, where I would specialize in tropical cyclone forecasting and developing products for tropical storms and hurricanes and trying to better predict those features for my PhD. And then from there, I kind of bounced around the country. I got my PhD up in Albany, New York at the University at Albany. And then I worked for several years in the Naval Research Laboratory in Monterey, California, where I got to participate in a number of different field campaigns, both into hurricanes and tropical storms, and then also other extracurricular things like wildfire-induced thunderstorms. And then from there, I applied to see if I could become a hurricane specialist, and I was fortunate to get a spot here down in Miami. And so this will be my third year as a hurricane specialist down here in Miami.
That is awesome. And, you know, I can kind of relate to you here, Philippe, because I have a kind of a fear of tornadoes. I just, who really likes tornadoes to begin with? Then I guess maybe there are a couple of people out there, but I can relate to that. And that's interesting that you turn your fear a little bit and turn it around and were proactive and actually delved into the science of it all. Speaking of the science of it all, let's actually get right into the meat and potatoes here. Like everything in science, pretty much, whoever comes up and invents a theory or whatever it's named after. So we have the Fujiwhara effect, named after a scientist, Japanese scientist Fujiwhara. I don't remember his full name offhand, but can you explain what he found and what is the effect that he's referring to?
Right. So essentially, the Fujiwhara effect is basically when two tropical storms or hurricanes get in close enough proximity to one another, they start to basically co-rotate around a sort of center point between the two systems. And so it's basically documenting the influence that a tropical storm might have on another once they get close enough to each other.
And what would be that distance, you say? Is there a general range when the systems that get that close that they would actually circulate around one another?
I mean, so there is a general range, but it kind of varies depending on the size of each of the tropical cyclones that are interacting with one another. So typically, we wouldn't start to think about whether or not some sort of binary interaction or Fujiwhara interaction takes place until the systems kind of get within, say, 500 kilometers from one another. So close enough that the outer portions of the circulation can start to sort of feed back on one another.
Okay, so now, is it always kind of the same pattern where you get maybe like a smaller system moving around a larger system, or are there different variations that you see? Maybe you can see two very intense hurricanes kind of spiral around each other. Is there anything to that?
So I would say probably like the more common type of interaction is where you have one much larger smaller storm. And so the smaller storm basically has a much sort of larger influence going around the storm compared to the much larger tropical cyclone, which isn't as influenced as much. But you do also get cases where there are two tropical storms or hurricanes that are about the same size and basically exert about an even amount of influence on each system. So you get all these sort of varieties and shapes and sizes of this binary interaction. And that's what sometimes makes it so tricky to actually forecast the track of these systems, trying to gauge just how much influence there will be and just how much deviation in the motion that will be caused by each of the other vortices.
Is there a, with so many different oceans in the world, do you find that this Fujiwhara effect occurs in a certain particular region or a certain ocean? Is there any sort of pattern there?
Right. So, I mean, you can get Fujiwhara interaction that takes place in any ocean basin that you do get active tropical cyclones. I would say it happens most often in the West Pacific Basin because that simply is the basin where you get often the most tropical cyclones, and the most sort of number of tropical cyclones that occur consecutively or at the same time. And so obviously that's an important component. You need to actually have two systems that get close enough to each other. And so that just happens most often in the West Pacific Basin. And that's why that basin, you often see this type of interaction occur more often than some of the other oceans where you don't get as many often systems that are happening at the same time.
Yeah, it was really hard when I was kind of researching this as a topic for the podcast to actually go to any site, never mind the National Hurricane Center, and try and find, is there a record listed? And the response I got was not really. There isn't too much of a record on this type of stuff. Is that something that you guys at the National Hurricane Center, as a specialist, would like to try and, because we're always trying to what's the word? I guess we're always trying to put into written form, I guess is what I'm thinking, write it down and record information on just about anything that's out there, weather related. And this is one of those rare things. Is that something that you guys are talking about?
Right. So, I mean, there is some literature that's attempted to sort of document the sort of, climatology of Fujiwhara interactions, but I don't think there is one main record that basically keeps a track of all the tropical cyclones that have had these sort of interactions. And I think part of the reason why that's the case is because it's a relatively infrequent phenomena. You probably only see this maybe like once or twice a year globally. And then on top of that, different basins are being managed by different organizations and where they're cataloging and tracking each individual tropical storm and hurricane in the given season. And so really, I would definitely like to see kind of a better way of cataloging these types of events since they are very unique and do possess pretty unique forecasting challenges for us at the Hurricane Center.
Yeah, you actually just kind of answered my next question, which is roughly how many times can this effect take place during the course of a hurricane season? And it's very, very rare. Obviously, you said two times or maybe three times throughout the globe, on a yearly cycle.
Right.
One question I didn't, we were chatting a little bit before we actually got into the recording, and I didn't actually bring this up, but this was a thought that I had occurred to me as we were discussing. Does the ENSO pattern, ENSO oscillation, come into effect here? A La Nina or an El Nino season? Does that have any sort of effect on this as well? I mean, we kind of know that it does have some sort of impact in the amount of hurricanes in a season, but would it have any impact here in this situation?
So I guess the way that like ENSO could have a potential impact on binary or Fujiwhara interactions is that if you increase the number of tropical cyclones that are occurring, like in the East Pacific Basin, for example, then that would probably also increase the potential of multiple tropical cyclones occurring at the same time, close enough to one another that this sort of influence could start taking place. And so that would be kind of the way I would look at it, that El Nino events tend to enhance the number of tropical cyclones that occur in the East Pacific Basin. And then by a byproduct of that, you're more likely to have these sort of multiple tropical cyclone interactions taking place.
Wow, interesting. Are you researching anything now? Or what are you working on specifically as a specialist within the Hurricane Center? What are some of the things that you're looking at here as you go forward?
So I mean, right now we're in the hurricane season, so we're kind of in the thick of operations where we're actually doing regular shift work when we're forecasting tropical cyclones. So for example, I just came off a set of shifts where I was forecasting for what ended up becoming Hurricane done out in the open Atlantic and the central Atlantic. And I think that's just been declared. The last advisory just came out not too long ago on that system. But oftentimes during the off season, when we're not forecasting operationally, we do have some time to kind of dive into both the statistics for our forecast products, but also look at other sorts of phenomena such as like Fujiwhara interaction. And I did do, actually, this is not something I've really touched recently, but when I was a grad student, I did look at these sort of like size circulations and how they influence each other's motion. And so I did some research on what were called Central American gyres over Central America. And one of the cases that I studied was a very large, broad circulation that influenced the motion of a hurricane in 2005 named Hurricane Stan. And the reason why we were interested in this event is because Stan kind of deviated further south in its motion relative to what the forecast was originally. And it turns out that there was this larger scale circulation that was influencing its motion. And so there's some similarities to that and say like two tropical cyclones of different sizes that could interact with one another and some of the steering deviations that take place due to those effects.
Yeah, there's a lot to be learned out there. I mean, as far as we have come in just to say the last quarter of a century here with regards to intensity even of hurricanes and all of that, there's still so much more that can be learned from what's out there Mother Nature is bringing us. One last question here, looking forward to the future, what are your plans with hurricanes? I know obviously you're in season, but when you're out of season, what do you guys typically kind of do? Because a little insight, people really don't know. I mean, they know you're busy when it comes to this time of year, but when November 30th hits and right till June 1st, what are you guys kind of working on?
So yeah, so we're still quite busy even after the end of the hurricane season, because the first task is basically we're reviewing and evaluating all the tropical cyclones that took place over the hurricane season. And so we conduct these so-called tropical cyclone reports that basically go through the whole nuts and bolts of what happened during a given tropical cyclone. It also compiles a lot of the data. So if a storm makes landfall or there are a lot of surface observations, we incorporate that into the report. And we basically, it's the best tracked record of that system, because we like to go through after the fact and like look and reanalyze all the data to make sure that we've done the best job analyzing that tropical cyclone over the given hurricane season. And then in addition, we do a lot of outreach in the off season too, where we're actually going to a variety of different venues and conferences. We're talking with the general public, emergency managers, and other partners that we are collaborating with during the season to basically keep strengthening those relationships and coordination between what we're issuing out for hurricane watches and warnings and making sure the message is getting out to emergency managers for those that are making very critical life-saving decisions such as evacuation orders. And so we're kept quite busy even after the hurricane season is done, both doing the outreach, writing the reports, and then if we have some time, also doing some sort of research that helps to improve our forecasting and verification process.
Can you give us a little tidbit into anything on that note, anything that you guys are looking forward to moving forward into the next season on the research side of things?
Sure. So, I mean, like one of the biggest things that we introduced this past year is actually we're now doing 7-day tropical weather outlooks instead of 5-day. And that came out of research basically of seeing that our forecast accuracy for forecasting the development of a tropical cyclone had improved over the past 3 to 5 years, and we could start extending that time range further out in time. So another thing we're sort of experimenting with is 7-day tropical cyclone forecast. So right now we only do a 5-day tropical cyclone forecast for both the Atlantic and East Pacific basins, but we're hoping in the next 3 to 5 years, as our forecast accuracy continues to improve for both track and intensity, that we could then extend that out to 7 days. And so that might be coming down the pipeline, not immediately, but hopefully in the years to come as well.
Excellent stuff. Well, great. Thank you so much, Philippe, for spending a few minutes of your time to discuss a very interesting subject to me, and I'm sure to others, in the Fujiwhara effect and how that is a part of our natural landscape. It occurs not too often, but every once in a while. So that's some good stuff. And again, some great insight here onto what you're working on at the Hurricane Center down in Miami. Philippe, thank you so much. Have a great rest of the week and a great weekend coming up.
Thank you so much. I appreciate this. This is great.
Yeah, it was a great interview. Philippe, thank you again, hurricane specialist there, Philippe Papin, and talking a little bit about a subject called the Fujiwhara effect and how storm systems interact out generally out in the Pacific, but also there have been those storms and interacting the same in the Atlantic and as well as also the Indian Ocean too. It's occurred all across the world. Well, that will wrap it up for this week's Whether or Not podcast. Of course, as always, stay cool, stay good, God bless, and we'll talk again next week.